Hello, this is Dr. Michael Hassan, the engineering doctor, and this is lecture number 40, Synchronous Counters Design with T, Flip-Flops of Chapter 7, Counters and Registers of the course Digital Logic Design or Digital Systems or Digital Electronics. This is a disclaimer for you to read. I cite 3 references in Digital Logic Design, however there are many books. In Chapter 7 contents, we talked about introduction to digital counters, ripple and asynchronous counters, binary ripple down counters, binary ripple up-down counters. We talked about other ripple counters and synchronous counters. Then we talked about design of synchronous counters using D flip-flop. And in this lecture, we will talk about design of synchronous counters using T flip-flops. As a reminder, the T flip-flop characteristic equation is Q plus T, Q prime, or T prime Q, or T exclusive or Q, or we can say T, it's Q plus exclusive or Q. And the state table and the state graph of the T flip-flop is we have the present state Q and the Q plus. So this is the excitation requirement table. If the transition from 0 to 0, T must be 0, 0 to 1, T must be 1, 1 to 0, T must be 1, and 1 to 1, T must be 0. Simply T is Q exclusive of the Q plus. Now, we will design actually mode 8 synchronous counter using T flip-flop. Now, with this in mind, so we know actually T would be Q plus exclusive or Q. So TA will be A plus exclusive or A, or TB will be B plus exclusive or B, or TC would be C exclusive or C plus. Now, if we look at this table, this is the state table for mode 8 counter. If we are in state 0, 0, 0, the next state will be 0, 0, 1. If we are in state 0, 0, 1, the next state will be 0, 1, 0, and so on and so forth until we reach 1, 1, 0, the next state 1, 1, 1. If we are in state in 1, 1, 1, the next state will go 0, and the circle will go around and around, okay, the state graph. So with this in mind, we generate TA, so we can say 0 plus 0 or exclusive or 0 is 0. See, we see 3 zeros here will be 0, 0, 0. This 0 exclusive or 1 will be 1. Then we have 1 exclusive or 1 is 0, 1 exclusive or 1 is 0, 1 exclusive or 1 is 0. Then 1 exclusive or 0, which is modulo 2 addition, it means 1 plus 0 is 1. So what we end up with TA. The same thing, we generate TB and TC. So according to the design procedure that we covered in the previous lecture, once we have this TA, TB, and TC, we can go and establish K-maps. One for TA, one for TB, and one for TC. We have A, B, C, 0, 1, 0, 0, 0, 0, 0, 1, 1, 1, 0 for TC. And this is filling out the map should be now easy for you because we've done it so many times. Just we go to TA, we have 0, 0, 0, 1, 0, 0, 0, 1. And this is what we see. TA 0, 0, we jump 0, 1, 0, 0, 0, 1. So we have 2 ones, we group those 2 ones as a group of 2. 0 will cancel with the 1 for the A, and TA will be simply equal to BC because B is equals to 1 and C, so it is BC. The same thing with TB, we fill up the map, and we end up with a group of 4. 0 will cancel with the 1 for the A, 0 will cancel with the 1 for the B, so I have C. So TB will be equals to C, and the K-map yield, the K-map for TB yields, TB will be equals to C. However, for TC, we have all ones. As you can see from the table, we ended up with all ones. So the map will be filled, all the midterms equal to 1, and 1, 1, 1, and this is group 8. Everything will be cancelled out, so here will be 1, and here will be 1 on the vertical side, 1 and 1. TC will be 1, and TC will be 1. So once we have this, we can really draw the network for the counter. We have 3 flip-flop A, flip-flop B, flip-flop C, because it's the mode 8, so we need 3 flip-flop. So we have TA, the input for TA is B and C. This is the output B, and this is the output C. So really B and C has to go here. Okay, it's not shown, those lines has to go here. And TB will be C, so, and TC will be 1, just we connect it to logic 1 input, and we have a complete counter, the logic network of the counter completely done. So design with T flip-flop is very simple, and it depends on the characteristic equation of the flip-flop, which gives me T, which is a Q plus exclusive for the Q, and we need to establish the K-map for, we have to determine the number of flip-flops, and since we have 8 states with mode 8, so we have 3 flip-flops because 2 to the power 3 is 8. This is very obvious. And we got the circuit, and this would be the end of this lecture. I would like to thank you so much for listening. Please subscribe by clicking on the blue circle with letter I in it. Hopefully to see you soon in the next lecture. Sincerely, Dr. Hassan.